Hello, welcome back to the Education on Fire podcast. Great to be back with you again. And today we're talking about mathematics and most importantly, how just doing 10 minutes a day, 3 days a week can make a big difference, especially if you're involved in the Elephant Learning Mathematics Academy. I'm chatting to their founder, Dr. Aditya Nagrath, and he's going to explain why mathematics is so important and how this way of learning can really be beneficial, and especially for not just learning now, but for your future as well. Really hope you enjoy this conversation. Hi, Aditya. Thanks so much for joining us here on the Education on Fire podcast. It's great to talk about maths. It's also great to talk about, I think, setting people up for learning, which I think is it's sort of integral to what it is that you've managed to sort of put into place. But I want to start first of all, elephant learning. Where did that come from?
Yeah, thank you for having me. Well, Elephant Learning is a project that we started in 2016. It came from a program at the University of Denver called Kids Play Math. And they were funded, I think, partly by the National Science Foundation and the Toyota Foundation. And basically, when I got introduced to the program, what I learned was that 4 out of 5 students start kindergarten unprepared for the kindergarten curriculum. And that's pretty hard to believe because, in the United States, kindergarten's supposed to be where it starts. Like, why aren't they prepared? And what I learned was that this was a language barrier. So, what kindergarten thinks is counting to 10 is, can you give me 10 things? And the student is able to slide over 10 things and stop on 10. Whereas most parents believe counting to 10 is just saying the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. In the first case, they're demonstrating understanding of the numbers, but in the second case, they could just be saying it out loud without any meaning. And so that's kind of where it started. We inherited their project, we rewrote it from scratch, and we built it so that it could run basically anywhere. And we expanded it so that it covers from pre-K and now it goes through algebra. So originally it was just pre-K and kindergarten, but now it's pre-K through algebra, expanding over the years. And that's basically where it came from.
And I guess that makes sense because once you're in that kind of idea of how do we learn, why are we doing it, and both sides, sort of the person sort of teaching it or being sort of that role model, as well as the pupil understanding how that works, that once the two things happen together, then you can take it, like you say, through the ages and through the different subject matter.
Well, so the challenge of expanding it was could we take activities from different researchers that are proven to teach mathematics as a language, and so like the way the standards define understanding multiplication from a language perspective is, can you use multiplication to solve a real life problem? So the way we end up approaching it is showing groups of and objects. So like groups of 7 objects. There's 4 groups of 7 objects. How many objects do I have? And then building the student up to understanding that multiplication is the solution to the question, 4 times 7. And then the memorization piece comes naturally because now you're memorizing something that helps you solve problems that you've encountered in real life. Whereas if you memorize those multiplication tables and you don't understand how to use multiplication to solve a real life problem, then it seems useless to you.
And do you think that's a key understanding that lots of people maybe overlook, is the fact that I sort of remember going into school, you kind of get in this mindset that you're just trying to do it to get the right answer. You're just trying to do what you think is what you're being asked. But maybe that understanding piece doesn't quite fit in that same kind of way. So what you're talking about here is such an important factor that you realize there's more to it than just that initial, I need to know that, like say 4 plus this equals X, or 4 times 7 equals this.
Yeah, I mean, this is kind of the key part of mathematics that maybe was overlooked when we were going through schooling, because back then, calculators weren't as proliferated as they are now. And so like it becomes a question of like, can we employ people to do mathematics? And so like to a lot of people, mathematics is something that you do. But the shift for me became like with this project, is mathematics something that you can understand? Is it something that you can then use to solve problems? And that shift is actually a very large shift because, um, first of all, you don't start to ask questions like, when am I ever going to use this? Because the uses become fairly obvious. What we see in students as they're coming through our system and they are understanding the mathematics is that they have more conversations with the parents. Even my child has more conversations with me that are mathematically based. They ask questions that are mathematically based. The example that comes to mind for me is that there was this parent who, emailed in and she was saying, my 5-year-old, my 4-year-old is talking about mathematics at dinner. And they're saying, like, well, there's 5 chairs here, but there are 4 plates. And, I don't really remember exactly all the details, but like these kinds of conversations then really take it back to mathematics is a language, right? And the real key here is that if mathematics is a language, then there are true statements and false statements, just like anything that I might say out loud. And so, like, the game of mathematics then becomes, can you identify which statements are true and which statements are false? And mathematics ceases to be something that you do, but becomes something that you then use in real life to solve problems.
And as someone who sort of took that well into your life in terms of going, getting your degrees and then using it in computer science and all the business stuff that you've done, do you think it's something that inherent understanding and then teaching enabled you to do? Do you think if you hadn't quite understood it in that way, you wouldn't have gone down that path? Or do you think there's a natural ability that helps you and you can get as far as you think you might be able to before you hit some kind of barrier? How do you sort of see it from that point of view?
Well, I mean, like everybody else, I went through the same education system. So to me, mathematics was something that you did. I think until about maybe the first or second year of college, because at that point, the subject matter starts to change. And rather than like, can you solve these problems, it becomes about like, here are these new ideas. Like, I think my first proofs course was topology. And so, like, there's an introduction to abstract ideas, like an open set, which we talked about on the real numbers, but now we're talking about it abstractly. Now it's some abstract properties. And what can you determine to be true? And can you write proofs that then show that these statements are true or false? And that was an interesting shift because I remember kind of looking at some of these items and thinking about, like, well, why didn't we just talk about it this way earlier? Right? Like, it'd be easier to understand these materials um, if we talked about the language earlier on. And then that's actually what the research ended up finding out, is that the students can understand very advanced topics at very young age. So like 4-year-olds during play will exhibit concepts as advanced as multiplication or division during play. But it's the adults in the room that don't think that they could understand it that don't label it. So it's like if we just use the language out loud, they'd learn the language in the same way they learn the rest of the language.
Which is an amazing concept because you wouldn't expect a child to learn lots of words and never understand what the story is about or what it is that they're reading when they're starting to read from a very early age. It's something which is is a skill that is sort of really tried to be sort of delved into from staff, because it's very much, yes, you've got these words now, but we need to understand what they mean and how they get put together and how you start to understand the grammar and how that makes the story come alive, or the information that you're trying to get from a piece of text that you're doing. So it's interesting that that same thing didn't apply from a mathematical point of view than it did from an English point of view.
Yeah, I mean, again, right? Like, if you recall, like, and there's movies about this, but to put a man on the moon, all of those calculations were executed by human beings. And so, like, yeah, they had rooms full of people just executing calculations. And so, like, from a philosophical perspective, the government had a job for you as long as you could do the mathematics, regardless of whether you could understand maybe what these guys were trying to do with the mathematics, what the engineers were trying to do with the mathematics. If you could just execute it for them and they could get the end result of the calculations, then they could move on. And this reminds me of that Oppenheimer movie, right? They it was like Einstein and Oppenheimer, and they're saying, "Well, I'm just not good at the math." That's not what they're saying, right? They were saying, "Hey, I'm not good at executing the calculations. That's why we give it to that room of people over there. I'm good at coming up with the equations. I'm good at looking at black holes and figuring out. I mean, there's a documentary on Netflix about people studying black holes, and they're like literally just looking at these things, coming up with equations to model it. That's pretty advanced mathematics, if you ask me. But if you're not executing the addition, well, then human beings don't call it doing math. It's just really weird.
Yeah, and I think that's something that missed me out through my learning was that understanding that it's not just another subject you're doing at school. The whole thing that you're talking about problems and trying to think about life and how all of it fits together is such a key area, which is why I love these conversations because it kind of brings these things to the fore sort of right from the get-go, as it were, rather than, like I say, it's something you get to later on. So it's probably a good point to talk a little bit about the sort of the program itself. What is it that people that get involved in what you do, how do they learn, how long is it, what does the structure look like, and then how does that sort of wind into the sort of thing that you've been saying?
Sure. Well, okay. So our system then, what it does is it takes the most effective activities at teaching mathematics as a language, and it combines it with adaptive algorithms so that we're always keeping pace with the student. And we start at their level of understanding by putting them in a placement exam, which is intended to start behind them and catch up to them because we want to build confidence on the way in that, yeah, you can do it. But at the same time, we want to ensure that the puzzles feel like a puzzle game, meaning that they start really easy and then they get harder as you get them correct. And so after we start at their level of understanding, the students are receiving puzzles. Some of them are definition type puzzles where we're telling them something like, here's the definition of a fraction, right? So like when you have 1/2, it means you take one whole thing and you split it into two equal pieces and you choose one of them. And if the student's going through them on their own, they tend to figure it out on their own, though we also provide mathematics coaches so that if they get stuck at any point in time, or if you want to kind of speed them up a little bit, you can meet with one of our coaches. Or if they're exhibiting anxiety, you can meet with one of our coaches. And we have an anxiety coaching program. Um, so altogether, when we measure results, what we see is that students in our system learn an average of 1.5 years of mathematics over the course of 10 weeks when they use it just 30 minutes per week. So our recommended usage is just 10 minutes per day, 3 days per week. And if the student does that, they should learn at least 1 year of mathematics.
Wow, that's amazing because I think people would just say that surely that can't be possible because, like you say, you know what you normally do. You like to say whether you're learning the timetables from rote or however you sort of been doing it before, but to see that amount of change in that amount of time is absolutely incredible. And I guess that's the thing about having so many people go through the system is that you've got all the anecdotal evidence as well as the statistical evidence to show that's the case.
Yeah, we just released a research study maybe 2 years back. It was 57,000 students. They used the system minimum 23 minutes, but average of about 39 and a half minutes. And on average, they learned 1.67 years of mathematics over 13 weeks.
And I know one of the things which is key to what you're trying to do is to make it sort of equitable in as much as understanding these things, no matter what your background, no matter what your experience is, being able to sort of understand maths in the way that we're talking about gives you the option to all sorts of further study, careers, understanding about being an integral part of society in order to move forward. So talk us a little bit about that and why it's important to you.
Sure. So when we looked at the data, the 4 out of 5 students that start kindergarten unprepared for the kindergarten curriculum happens completely along income lines, meaning that it's the top 20% income earners whose children enter kindergarten prepared. And everyone else kind of is behind where the lowest income earners are furthest behind. So on average, children in low income neighborhoods are 3 years behind their funded peers, and these are all statistics in the United States. But like what it turned out was that high income earners can afford to send their children to preschool, and in preschool they ensure that they meet the standard coming into kindergarten and they have the language that's necessary. But of course, high income earners also have a lot more time to spend with their children to ensure that they understand the language and speak with them about these things to see whether the understanding is there. And because of that, it looks like this basically contributes to the cycle of poverty, meaning that students that start behind tend to stay behind. There's very little catch up occurring. And your math scores tend to predict whether you drop out of high school. 69% of STEM majors switch to a major with less mathematics. It used to be that they would be switching to business, but now business is extremely statistically driven due to the infiltration of computing devices basically in every area of business. And majors that used to be extremely creative, like marketing, are now being run by companies like Google and Facebook, where being able to understand the algorithms and the AI and how everything's kind of working behind the scenes is sort of a big deal. So the majority of students end up switching to humanities, which in the last 2 years, ChatGPT has kind of threatened their livelihood as well. So it feels like mathematics tends to be something that's not important for the students, but in reality, mathematics is the tool, the basic tool that human beings use to solve almost any problem that they have in life, including communication problems. If you want to think about it as in a conversation, when there's a misunderstanding, you got to look for the X, which is what is the variable that hasn't been introduced to this conversation that the other person's missing that would then help them understand what I'm saying. And so the thing is it depends on how you want to look at it. But for the most part, most of your high income jobs require a lot of mathematics. For example, if you want to work on Wall Street, you got to be pretty good at math. Options trading is called derivative trading because it behaves a lot like derivatives from calculus. And it's just like for those people who get it, they just keep moving on. But for those people who don't get it, they kind of stay where they are. And so, yeah, for us, what we're doing to help students in low income situations is we have scholarship programs that makes the program more affordable for them. And it's kind of our way of helping to collapse the inequity.
Yeah, I love that. And you sort of talked about obviously the US there. In terms of people further afield, does the program work in the same way? Is maths, as it were, in terms of how you're learning it? So if people over in the UK here wanted to be involved as well, does it work out just as well?
Yeah, we've had thousands of students in the UK. We work on the essential topics of mathematics, so we're not trying to do measurements necessarily where people kind of get caught up in the difference between UK and US. If you understand fractions, decimals, and percentages, which is the same worldwide, meaning like if you go over to Russia right now, you'll see 40% off on store doors, right? If you can understand the language of fractions, decimals, and percentages, then it doesn't matter which measurement system you're working in, you're kind of understanding what's happening. But if you don't have that basic language, then these other topics become harder. And so by focusing on the essential topics, specifically as a language in English, people have benefited worldwide.
Yeah. I love it, and just while we're sort of still talking about the system and the project specifically, where did the name come from in terms of elephant learning? Is that something that came from the original project that you sort of took over, or was that something that came from you?
Well, yeah, that was us. So like our software company, we were running a contract software engineering company before we started this. Is called Elephant Head Software. So Elephant Learning was a natural transition or
Got it.
product name, if you will.
Sure. Yeah, yeah. I wasn't sure if it was the way, elephants learnt, or the fact that they, the idea that they could remember lots of stuff, or whether it's anything related to that, or or where that came from. It's such a memorable thing. I just thought it was such a great way of being sort of front of mind for everybody.
It works out great for us because we could say like big math learning and it makes sense. It really causes a lot of ability for puns, I guess.
Yeah, yeah, exactly. And in terms of how this sort of fits in with your educational experience from when you were younger, is there an educational experience or a teacher that you remember that sort of had an impact on your life, and has any of that sort of been brought into sort of what you're producing now?
Well, there's so many teachers that have had a large impact on my life, and I think every student for that matter. But like, I don't know if it necessarily fits into the program that we built because we built it based off of scientific research, right? So we kind of used the science to engineer, and then we engineered a platform that was kind of scientifically based so that we could measure the results in a very precise way. And then that way we could report the results in a very precise way. Um, but I mean, I remember my third grade teacher who took some time to help me with multiplicative thinking, and that's kind of also what our system does is we help teach multiplicative thinking. Um, but I'd throw a shout out to my PhD thesis advisor as well, Dr.
And
Richard Ball.
and I think anyone that sort of helps you just brings that human connection in. And I think in a world which is, like I say, can be very sort of sciencey or mass, where people think, oh, it's less human. I think one of the things that you've articulated so well today is the fact that it's essentially human, because it's about the conversations, it's about the problems we're trying to solve, it's about the understanding of what we're trying to do. So you can start to really understand how those two things go together, and the human and the personal are at the heart of everything that we do. And I guess that's why having so many people with their different experiences of how they've learnt and what education system they've come through sort of helps sort of galvanize all these things together. What's the best piece of advice you've ever been given, or indeed is there some advice that you might give your younger self now looking back?
Well, yeah, the best piece of advice, the story kind of goes like this, is I was in a course called uh, computer algebra. That's what it was, computer algebra. So we were building a computer algebra system kind of from scratch, but not really because it was kind of built on top of Mathematica or something like that. And I remember I was either working on like coding the thing for the derivative or the integral or something like that. And it was a piece where we were working with a partner. So I was telling them, hey, just let's throw this in and let's see if it works. And one of my professors was walking by. His name is Dr. Cohen. And he said, this is computer science. It's not computer guesswork. You're not supposed to guess. Think about it uh, before you try to put it in. And that piece of advice can literally work for any major, right? Because so many times as we're, growing up, we're kind of working off of trial and error, and that's totally okay. But at some point, if we do understand the materials, it's important to think about the materials and how we're using them so that we can achieve the goal.
Yeah, I love that, and I love these things which go, like say, across different subjects or different parts of your life, and all of those sorts of things, because there's a truth there, isn't there? There's a thread of something which connects with you in a way that you can sort of bring back in different situations, and I think those things are the things that often remind us the most. Is there a resource you'd like to share? And this can be anything from a book, a video, song, film, podcast. But yeah, something which you'd like to share.
So we wrote this year. It's on treating mathematics anxiety. So it takes our coaching program that our coaches are implementing, but it gives it to both the teacher or the parent so that they can understand what our coaches are doing. So like even if you read this and you still want to use our coaches, obviously, right? But this helps you be a good coach for your student at home, especially as mathematics is concerned. And maybe one of the main resources of the book is the basketball analogy. So it's a kind of a gamification of mathematics is what elephant learning is. And so like you're playing the game, which is mathematics. Meanwhile, you could be playing basketball. So basketball and mathematics are related in that anyone can look and see, did the ball go in the hoop or not? Where they kind of become unrelated is that like in basketball, there's absolutely no way for the coach to shoot as the player. And so like that's kind of one of these bases of math anxiety is that as human beings, we want to be able to help our students or our children. And so like we might then try to force the ball into the hoop, is the way I put it, by either giving them the answer or giving them a process, or what we're doing is we're shortcutting that thinking, that problem solving that they need to do in order to build the intuition into the problem. And so like this is one of the resources I recommend. It's on Amazon. I wrote the book, but I think it's extremely useful for anyone that's dealing with any type of mathematics anxiety or working with the student dealing with mathematics anxiety because it really kind of boils it down to, you don't have to worry about whether the ball goes into the hoop or not because it's always kind of about the next shot. This shot's already been taken, so like can't affect did it go in or not, but you could affect whether the next shot goes in.
Yeah, I love that. And I think for me it's so easy to want to do that shortcut, isn't it? It's so easy to kind of that sort of instant gratification, as it were, of doing that. And I certainly know as a musician myself, if I'm in a room and I'm sort of teaching the drums, there's that you could have just do this. And one of the things that I love is that one of the things that we have to go through is to learn how to do a snare drum roll. So it's like a buzz roll. So you've got a sort of a continual sound, which is basically just each stick kind of bouncing multiple times. And the thing that I love about it, and it's something which I'm not sure every pupil understands to begin with until after they've mastered it, is that I can say, this is how I hold the stick. This is how I go about it. This is even kind of some of the things I'm thinking about, but it's your experience of what that feels like when you're trying to do it is what you're learning. And I can't do that for you. And there's absolutely nothing I can do. I can explain a couple of little things. I can mention some things, but it's purely your learned experience and that repetition and that ability just to go through. And for me, it's always that sense of you have to really let go at that point and just allow that process, that continual trial and error. And it gets so much better, much quicker. But there is something about that moment, which I think is along the same sorts of lines that you're talking about, that you just have to sort of go with. And then the joy that they experience and the understanding and the leap forward above and beyond just the new skill they've learned, I think is a wonderful thing to experience.
Yeah, I mean that's really what it's all about. And then the inverse of it is if there was some way that you could beat the drum for the student, they wouldn't believe that they could do it. They believe that you could do it because they just watched you do it. And so that's kind of the tricky part about it is that like you have to allow the student to do it in these situations because even though it feels good for you to help them get the ball in the hoop, like when the ball goes in, it feels really nice. But if the student didn't do it, well, it doesn't feel nice for them. It feels like you did it.
Yeah, I love it. It's a great analogy, and yeah, it really just made me think of so many different things that I do, and I have to catch myself, and even when you think like say you have to catch yourself again, and just remember it's not your learning that's going on. You're facilitating the learning for the people, and that's why it's great having different people with different personalities that you're doing, and why I get fascinated by the sorts of things you're able to produce to have a system and a way to do it that works with each student, even though you're doing it for so many students at one time, which is such a gift for so many people. The
Yeah.
acronym FIRE is obviously really important to us here at Education on Fire, and by that we mean feedback, inspiration, resilience, and empowerment. What is it that strikes you when you see that word, or is there any one of those things that jump out at you?
Well, empowerment. So our mission over at Elephant Learning is to empower children with mathematics. So that's more than just learning mathematics. It's finding empowerment through mathematics. So if you have anxiety with mathematics and our system helps you overcome that anxiety, well, that's kind of the definition of empowerment. Empowerment is finding power where you didn't have power before. So that anxiety is like, yeah, I want to give away my power. I want to somehow blame someone else or push it off or, somehow not do it, right? Like avoidance strategies to not do it. And so, like, when the student starts to understand and they start to gain power over it and they start to then use it as a tool, that feels great, honestly.
Yeah, I love that. So, for those people who want to find out more and get involved and give it a go, tell us a bit about that. You have a free trial, I believe, and also make sure that they know which website to go and have a look at to find it.
Absolutely. Go to elephantlearning.com. You can just enter your email there and get started. Um, Basically, at that point, if you need a scholarship, please DM or email our support, and they'll help you get one of those. But that's the best place to get started. And from there, you'll be able to download an app either for iOS, Android, Amazon Kindle Fire, or you can use it on Chrome and Safari. And if you want to learn more about the book, that's also on the website, but the best place to get it is from Amazon, especially in the UK.
Fantastic. Aditya, thank you so much for such a wonderful conversation. I've really enjoyed this sort of insight into the human, I think, element of this sort of subject matter and the way that you've gone about it. It's been absolutely fascinating. So yeah, thanks for your time and yeah, keep up the great work.
I appreciate it. Thank you for having me here today, and I enjoyed the conversation as well.
Education is not the filling of a pail, but the lighting of a fire.